In example 4, we are requested to sketch the graph of y is equals to 4 cosec x, and within these limits, negative pi to pi. And then part B, on the same set of axes, you sketch the graph of y is equals to x. And then part C, stick the number of solutions to the equation 4 cosec x minus x is equals to 0 within the two limits. First of all, it must be known that the graph of y is equals to 4 cosec x is simply the graph of y is equals to cosec x, which has undergone a transformation of multiplication outside. And we all know when we have multiplication outside, we have multiplication outside, which is a vertical stretch of scale factor a. And in this case, our a happens to be 4. That means all the y values are supposed to be multiplied by 4. So if we have something like this, and this is simply a sketch, assuming that we have probably pi over 2 and we have pi there. This is negative side. And we happen to have pi over 2, 90 degrees, and pi there. Basically, what we saw in our previous video is that along the line negative pi and 0 and positive pi, we had an asymptotes. And when we have 1 there, 2, 3, 4, 5, and the same case, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. Let's see what happens. 1, 2, 3, 4, 5, and moving forward. So we saw in the previous video that the graph of y is equals to cosec x is a graph that is moving from this particular point and turning it around when y is supposed to be negative 1. But because we have vertical stretch of 4, meaning that all the y values are going to be multiplied by 4, that means it's going to take a turn at that particular point. So we are going to have such kind of a graph. And the same case applies here. This will be the turn. So we are going to have such kind of a graph. That is as far as part A of the question is concerned. Part B, we are told that on the same set of axes, sketch the line y is equals to x. And of course, when y is equals to x, of course, when x is equals to 0, y is 0. But let us consider when x is equals to pi. Pi, so to speak, if you evaluate the value of pi, is equals to approximately 3.142. So when x is pi, which is 3.142, and within the equation y is equals to x, then we should have the same kind of value of y. So when x is, let's say, 3.142, y should also be 3.142 there. And when x is minus the same, y should be minus 3.142. And of course, it's passing through the origin because the equation is y is equals to x. So with a very straight line, let's talk about a graph that looks like that, a very straight line. We name it like y is equals to x. And you can see the curve, this is the graph of y is equals to 4 cosec x. And the two graphs are in the same set of axes. Now, part C of the question. State the number of solutions to the equation for cosec x minus x is equals to 0. To start with, this was the value of y here. And this was the value of y when we are dealing with y is equals to x. So in other words, we must be talking about the point of intersection. The two graphs are supposed to be intersecting. But according to the nature of our graphs here, according to the nature of our graph, we realize that y is equals to 4 cosec x and y is equals to x. They do not intersect. Of course, within the range of negative pi all the way to positive pi. Within this kind of range, the two graphs do not intersect. And therefore, the equation this one has no solutions in the given range, simply because this one has no solution within the given range because the two graphs do not intersect. They do not, because the two graphs really, they do not intersect. And that is that's the fact, that's the truth of the matter in that particular question. There are no solutions because the two graphs, they do not intersect. All right?